Welcome back to Join Mathematics, and let's consider now the magnitude of a vector. Magnitude of a vector. Sometimes people call it modulus, but let's go with magnitude. Now, we call these types of question where we are asked to evaluate the vectors in the format of xy. So we have OA, 3y, 3, 5, EF, -3 and 4, and likewise OC, which is -6, -2, and IJ, which is 2, -4. So let's begin. We want to evaluate the modulus of OA. Okay, the modulus of OA is written as OA because if we have a vector, okay, R, which, okay, let's use a black pen. If we have a vector R to be a component of x and y, the modulus of the vector R will be the square root of x squared plus y squared. Okay, because we are applying Pythagoras theorem. The reason being that if we look at this now, we have how many units on the y axis? We have 5 units, and on the x axis we have 3 units. So we are asked to evaluate the distance. Modulus is distance of this. Now with that done, all we just have to do is to apply Pythagoras theorem, because this is a right angle triangle, and we know in Pythagoras theorem the hypotenuse squared, okay, is equals to the adjacent squared plus opposite squared. All right, and the hypotenuse will therefore be equal to the square root of the adjacent plus hypotenuse. So if we take a quick look at this now, we can see that we have the two sides 5, okay, and 3. So when we apply Pythagoras theorem to this, we can easily evaluate our OA, and our OA therefore will be equals to the square root of 3 squared plus 5 squared, and which applies to this when we have xy, okay, the modulus will be the component on the x squared and the component on the y squared. So this will give us 9 plus 25, and 9 plus 25 is equals to 34. So we have with 34 units. That's for the modulus of OA. And now let's move on to the modulus of EF. Now EF has how many units on the x? Let's look at EF. EF is -3, 4. It has 3 units on the x-axis and 4 units on the y-axis. So therefore we can say, since EF, okay, since EF is equals to -3, 4, okay, because it's 3 in the negative direction, that's -3. Therefore we know that the modulus of EF will be equals to the x component squared, that's -3 squared, okay, plus the y component squared plus 4 squared. We are applying this principle, and this will result into 9 plus 16, which is root 25, which is 5 units. All right, so moving on, let's evaluate the modulus of OC. OC. Now OC has how many components on the x-axis? 6 components on the x-axis, but in the negative direction. That's why we have -6. And it also has 2 components on the y-axis, but in the negative direction. That is why we have -2. All right, so now the modulus of OC, okay, will be equal to the square root of the x direction, that's -6 component on the x, and the square on the component of the y. So this will result into 36, okay, plus 4. Yeah, so this will become square root of 40 units. So the modulus of OC is the square root of 40 units. Same thing applies to ij. Ij, which has 2 components on the x-axis and 4 components on the y-axis. 2 components on the x, 4 components on the y. So we can evaluate the modulus of ij, which will be equals to the square root, the component on the x, 2 squared, the component on y, minus 4 squared. So with that done, this will give us 2, that's 4, plus 16. And this will result into 20 units, with 20 units. So now we have the magnitude of a vector. So in conclusion, how then do we simplify a vector, the magnitude of a vector? So we have r is equals to xy. The magnitude of the vector r, or the modulus of the vector, is equals to the square root of the square of the x component added to the square of the y component. So let's take a quick example on this now. So if we have 1, p is equals to 3, 5. The modulus of p, or the magnitude of p, will be the square root of 3 squared plus 5 squared. That's 9 plus 25. Alright, and this will be equals to root 34 units. Likewise, if we have q is equals to 1 minus 2, the modulus of q will be equals to the square root of 1 squared, okay, x squared plus y squared plus minus 2 squared, and this will be equals to the square root of 1, okay, plus 4, which will give us root 5 units. Similarly, if we have r can be a vector of minus 4, 3. So the modulus of r, if we simplify that, it will be the x component minus 4 squared plus y component 3 squared, which is equals to 16 plus 9. And this will be equals to root 25, which is equals to 5 units. So we can have more questions on modulus of a vector. The most important thing is to apply this principle, that the magnitude or modulus of a vector is the square root of the sum of the individual square. So we say the square root of the sum of the individual